Welcome to Ask and Learn.
So in this problem, we have a ball connected to some rod, and we want to find the angle when the compressive force on the ball is 0. So we'll call that F, and we're given the weight of the ball, which is 15 pounds. Let's convert that to mass by dividing by 32.2 feet per second squared. So for the mass, we get 0.46 kilograms, and we're told that initially at rest the angle is 0 degrees. So it starts when the ball is straight up. So now let's think about the forces involved on the ball. So if we're saying we want to find the angle when the compressive force is 0, the only force acting on the ball is the weight in the x direction. So the weight in the x direction is mg cosine theta is equal to, Newton's second law is force is equal to mass times the acceleration, and here the acceleration it experiences is centripetal acceleration. So what we want to find is this angle theta. We can expand this a little bit. We can say mg cosine theta is equal to the mass, and then the centripetal acceleration is the velocity squared divided by the radius of curvature. And for this problem, this is the length of the rod, which is 3 feet. So now let's go find the velocity. So since we're dealing with movement, there has to be a kinetic energy involved, and velocity is embedded in kinetic energy, and the ball is at some height. So we know that there's potential energy as well. So we can use conservation of energy, and that's the initial kinetic energy plus the initial potential energy is equal to the final kinetic energy plus the final potential energy. You know that initially the ball is at rest when theta is equal to 0 degrees, so the initial kinetic energy is 0. And if we want to say at that rest point, we'll call that the initial height 0, so then the potential energy is 0. So then we're just left with the final kinetic energy, 1/2 m v2 squared. And then the potential energy is minus mg h2. Since the movement is to the right, the height gets smaller, so it's a minus mgh2, and all that is equal to 0. So to find the velocity, we need to find the height. So if we think about this, initially the ball is straight up, we'll call that point A, and then it moves to the right, and then it reaches some angle when the compressive force is 0, and we know that the length of the rod is 3, and also initially the length still remains the same as well, but this creates a tiny little triangle, right? We have like that. So we can call this y, and we can call this x. So this is a triangle on its side. So to find x and y, we use first cosine theta is equal to x over 3. So then x is just 3 cosine theta. So then to find y, and y is actually our h2, our height, then we use the Pythagorean theorem. So we have 3 squared is equal to x squared, which is 3 cosine theta squared plus, and then y squared. And then we move this to the left side and take the square root to get rid of the square. We have y is equal to 3 minus 3 cosine theta. And this, of course, is our h2. So now we can plug that back in and find the velocity. So we have 1/2 m. So 1/2 of 0.46, so we have 0.23. And then the velocity v2 squared minus the mass 0.46 times gravity. And in this case, gravity is 32.2 feet per second squared. And times height h2, which we just found, 3 minus 3 cosine theta. And of course, all of this equals 0. So we can simplify this a little bit. So all this right here, we can move to the left side. So on the right side. So on the left side, we still have 0.23 v2 squared is equal to all that on the right, which is 45 minus 45 cosine theta. So if we factor out a cosine, it's just 1 minus cosine theta. Now we divide by 0.23. So we get v2 squared is equal to 193.2 times 1 minus cosine theta. So now this v squared we can finally plug back in to our very first equation. This one, here's our v squared. So when we plug it in and plug in the other stuff we know, we have, so on the left side, we have the mass times gravity, which is just the weight, and that's 15 pounds, times cosine theta is equal to, well, the mass, 0.46, times the velocity squared, which we now know is 193.2 times 1 minus cosine theta. So now if we just move stuff around on the left side, we have 96.6 cosine theta is equal to 193.2 minus 193.2 cosine theta. And we just keep going with this. So now we have, moving the 193 this to the left, we have 289.9 cosine theta is equal to 193.2. So then cosine theta is equal to 0.667. So then solving for theta, it's just theta is equal to cosine inverse 0.667. So then finally our angle theta and the compressive force is 0. It's 48.2 degrees.